Welcome to Extra Science Academy, and in this video I'll be showing you guys on how to answer questions based on momentum. Right, so now we got this question 4. So now it says that ball P has a mass of 0.16 kgs moving east, right, at a speed of 10 meters per second. And then they say it collides head-on with another ball Q, right, a mass of 0.2 kgs moving west at a speed of 15 meters per second. After the collision, ball P moves west at a speed of 5 meters per second, as shown in the diagram below. Ignore the effects of friction and the rotational effects of the balls. Right, so we're going to ignore all of that, right? So now, before the collision, right? So over here, the most important thing, you need to be able to analyze the information, right? So question 4. So now we got before the collision, right? So before the collision, we know we got two balls, right? So we got ball P and ball Q. So let's write all the information. So now for ball P, we know the mass for ball P is 0.16 kgs, right? And it was moving east. So another important thing about momentum is direction. Direction is very important. So now we're going to take east to be positive and west to be negative, right? Since our motion over here is horizontal motion, right? So we're going to take east to be positive. So this before the collision, we know it was moving at v initial was 10 meters per second, right? And okay, that's it. And then mass for ball Q was 0.2 kgs, right? And v initial for Q was what was it, 15 meters per second. But now in this scenario, they said it was moving west, and west is what? Negative. So you're going to take that to be what? Negative, right? Negative 15 meters per second. Right, now this is before the collision. Now let's come after. What happened after the collision, right? So now after the collision, we got ball P, same mass, which is 0.16 kgs, and V final for P. Do we know the V final for P? Oh yes, because now it says that it was moving 5 meters per second west, so it will be negative 5 meters per second. And then for ball Q, you're going to have mass is equal to 0.2 kgs, and then V final Q, which is equal to do we know that? No, we don't have any information about that, right? So we don't have that information. So this is how you analyze your information, right? To be much more easier. Now for 4.1, now they're asking us define momentum. So we know the definition of momentum says that momentum is the product of its velocity and mass, right? So momentum of an object uh, it is product of mass and velocity. That's it. You can put it in your own words, that's fine, right? So now 4.2, now they're asking us calculate the velocity of the ball Q after the collision. So now over here we're going to use a formula which says the sum of momentum before the collision, it will be equal to the sum of momentum, right? Momentum after the collision, right? Because the conservation of momentum over here is conserved, right? So the momentum before will be equal to the momentum after. So now you're gonna say mass of P, right, times V initial of P plus mass of what? Mass of Q times V initial of Q will be equal to mass of P times V final of P plus mass of Q times V final of Q. Right, now let's start working out. So we know mass of P is 0,16, and V initial for P is what? 10, plus mass is what? 0,2, and the V initial for Q is what? Negative 15, right? Is equal to mass of P, which is 0,16, and V final for P is negative 5, plus mass of Q, which is 0,2, and then V final for Q is what we're looking for, right? So now they ask for the velocity, right? So now we got our calculators over here. So now let's punch in, let's calculate this side. So now this side you can have 0,16 close bracket times that by 10 close bracket plus 0,2 close bracket open bracket negative 15 close bracket, and we can put that in decimal points, negative 1,4. So we get what? Negative 1,4, right, is equal to, now let's calculate on the other side. So now we can take the calculator this side. Now we have 0,116, right, times negative 5 close bracket, and this is just going to give us negative 0,8, negative 0,8 plus 0,2 VFQ. So guys, please do not try and add these two together, right? Because these are two different terms. Don't try and add that, right? Because this 0,2 is part of VFQ. Are you guys saying that, right? So don't try and add that. So now over here we can transpose this side. Since it was negative, it will become positive. So negative 1,4 plus 0,8 is equal to 0,2 VFQ. So now you can take a calculator again. So now we're gonna say negative 1,4 plus 0,8, which will give us negative 0,6. Negative 0,6 is equal to 0,2 VFQ. Now we're going to divide that by 0,2, divide that by 0,2, that and that is going to cancel out. So VFQ will be equal to, now you can punch this in the calculator. So I'm going to say answer divide by 0,2, which is going to give us negative 3 meters per second. So remember, you don't stop here, right? So now you're going to say VFQ will be equal to 3 meters per second west. Direction is very, very important. 3 meters per second west. So remember, direction is very, very important over here, and that will be our answer, right? So now let's continue. So now they're asking you for 4.2. We can work it out over here. 4.2.2, they're asking magnitude of the impulse. So now impulse means changing, is the same as saying impulse is the change in momentum on the ball P during the collision. So over here, impulse, we know F net is equal to change in momentum all over change in time. So now we can say this all over 1, cross multiply. So now F net times delta T will be equal to what? Change in momentum. So now this is impulse over here, right? This is impulse, right? Impulse is the same as what? Change in momentum. So now in this scenario, we can't use F net times, because we don't have time and we don't have any force over here. So now we can work, because now they want the impulse on ball P, so we can use the information on ball P, right? So now we're going to say mass, open bracket, V final minus V initial, right? Close bracket. So now mass Mass in this scenario, mass for ball P is 0,16 open bracket. V final we have, which says -5 minus V initial minus 10 close bracket. And now we can work this out. Now you can take your calculator. So now you're going to have 0,16 open bracket -5, right, minus 10, right? And now your final answer is going to be negative 2,4, right? So now you're going to be having your final answer is negative 2,4. And the SI for your change in momentum can be written as kg, or we can say the SI unit, we can say kg meters per second. You can say that, or you can have Newton per second, right? Newton per second, right? We can have that as our final answer, right? So over here, guys, thank you guys for attending, and that's it for today, and I'll catch you guys next time. Take care.